We are now on module 5, that is about work and energy. And let's start our discussion on the first lesson, that is about work energy method for constant forces. So we're going to explore what is work, what is energy, and how they are related to each other, and why we discuss this one, what is its application in terms of the dynamics or in terms of the motion of our body. So we're going to explore that one. By the end of this discussion, you will be able to understand the concept of work energy theorem. The second one, you'll be able to understand the fundamental work energy equation, no? So equation ni siya kay usaraman siya for rectilinear translation. And lastly, you will be able to apply the work energy method in analyzing rigid body systems that is subjected to constant forces. So let's start with the principle of work energy theorem. So let's start with the word work, no? So work, as we all know, that is the product of the applied force and the object's displacement. In your physics class, so you have already defined this one. You have an idea that work is just a force multiplied by the distance, no? In our discussion here, we are going to change the distance into displacement because we're talking about vectors, no? In which our distance has a direction. So displacement ang ato ang gamiton. And then, as you can see in this figure, so a man pulls this block, no? So he pulls the block at one, or from one point. Let's say this is point 1 to point 2, no? So in order for this man to pull or to transfer or to change the location of this block from point number 1 to point number 2, of course, uh, he needs to have an an adequate force, no, to pull this block from point 1 to point 2. So that is why uh, the kanang parameter used to describe that one is work, because work again is force. So in this picture, the force comes from the pulling force of the man, and then the distance is defined as the length between the first position and the second position. So this is our distance, no? That is our distance. Okay. So next, energy. So energy, it is defined as the ability to do work, no? So I think you already through with your thermodynamics class, no? So energy can be transformed from one form to the other. So of course, in our figure here, so Iman possesses chemical energy, no, inside his body from the food that he ate, and then that chemical energy will be transformed into kinetic energy or mechanical energy. Okay, so that is why iya gipul ang ato ang block, and then the energy from the man transfers to the block, and that is why the block moves from the initial position towards the final position. That is why kanang i-transfer siya, no, from one place to the other. So again, energy and work are kanang related. So without energy, we cannot do work, because of course di ta kabunlot kung wa tay kusog, no, in simple terms. So interrelated ni siya ang kaning work of energy. So to combine these two concepts, we have here a theorem. So it states that the work done by the sum of all the force acting over any particle or object is equal to the change in the kinetic energy of the particle. So when we do work to a certain object, so that object will move, no? So with that behavior, so ang object nato nag-possess na siya o gitawag og kinetic energy because kinetic energy is the energy in motion, no? It is a function of the velocity. So with this statement, we can also create a general formula for our work energy theorem. It states that we equate work into energy, no? So the left side of the equation is our formula for work, whereas the right side is the formula for our energy, specifically kinetic energy. So kung magbirat tag butang, ang kanang butang madagit, unya nana siya velocity kay nag-move naman siya. So ang work sa left side, that is force. So the pulling force that we exert on the object, no, force, and then times delta S. So delta S is our displacement. So of course, once we pull the object, so it moves at a certain distance, no, or at a certain displacement. So that's why delta S. And then we equate that one, no. We equate that one into the energy, no, that is being produced or that is being transferred from the man towards the object, and that is in a form of kinetic energy. So that is why we have here 1/2 wg delta v square. So this is a famous formula for kinetic energy, that is 1/2 times the mass and the square of its velocity. Okay, so don't forget about this one. Next, we are going to derive the work energy equation for rectilinear translation. So we already know this one, no? So I have already shown this to you ahead before the derivation so that you have an idea. But where does this general formula comes from? That is why diri as ang slide, we are going to derive the general formula. So asa man nagikan iya derivation. So diri siya nagikan sa kaning duha ka mga important nga equations, no, sa dynamics. First is the Lambert's principle, in which the sum of all those external forces that we applied on a certain object is equal to the resultant force, no? And that resultant force is a function of the object's acceleration. So we already know that one, Wg times A. And then we also use this one, no? The familiar kinematics equation. So the first, no, kani siyang left side nga equation, this is kinetics equation, whereas the right side, this is kinematics equation, wherein the form is a differential equation is yan, no, because of the presence of differential coefficients, no, ds and dv. So we have the instantaneous acceleration times the change in displacement is equal to the instantaneous velocity times the change in velocity. Now, from these two equations, there's a common parameter, no, or a common variable, and that is our instantaneous acceleration a. Now we can modify the second equation into this form, no, a equals v dv over ds, and then we are going to substitute that one, no, or we're going to input this in our kinetic equation, and this will happen, no, eliminating a in these two equations. So it will now become summation of force times the distance, no, or displacement is equals to wg v dv. So this is now our differential equation that relates work and energy, but we cannot use this one because this is still in a differential form, no. It still contains differential coefficients. So what we need to do here is to find the general solution of this differential equation. So we integrate both sides of the equation because this differential equation can be solved right away or immediately because nakaseparate naman ng mga variables, no. So integrating the differential equation, so integral from 0 to s summation of force times ds, and then we're going to extract wg because this is constant, no, mo na siya sa gawa sa ato ang integral expression, tapos v dv. So we all know the equivalent integral of this one, no? V dv is just v squared over 2, di ba? Evaluate nimo from initial velocity to the final. So therefore, may nga na yung forma, no? 1/2 wg final square minus initial square. And then if constant ang forces, so if this summation of force is constant, so therefore this one can also be integrated, no? So if we integrate this one, assuming that the force is constant, wherein force is not a function of displacement, no? Take one, F equals C or constant. So therefore this one will be simplified into this form, Fs na lang, no? Fs evaluated from zero displacement up to the final displacement, or just put summation of F. So that is why for constant forces, this equation will reduce to this one, no? So summation of forces times iyahang respective displacement is equal to 1/2 wg final velocity minus the initial velocity squared, yun na silang duha. Okay? So this is how the general formula kanang came to be, no? From these two important equations lang. Kaning kinetics, and this is the first one, kinetics, and the second one, kinematics. Okay, so notes to remember for work energy equation. The first is by its unit, no? You need to be careful, no? Sa iya units. Kay para dili ka masipyat while having your calculation, no? Or upon formulating your solutions. So for work, let's explore by unit analysis. So again, work is the product of force and the displacement. So for English, or for metric, force is expressed in Newton, and then the displacement in meter. So that is why the unit of work is Newton meter for SI. And for English, so ang force is expressed, no, in pounds, and then displacement in feet, no? So we have here foot pound. Now, murasig na bali, no? Kay kung ato parehason sa format sa SI, dapat pound foot na siya. But most of the time, ang gipang use sa books kay foot pound, baliktad. Well, anyways, they are the same raman gihapon. Now, let's proceed to the energy. So for energy, let's explore. The formula for energy is equal to 1/2 Wg delta V square. So for SI, the unit of weight is Newton. For the gravity, meter per second square. And then the square of the velocity is meter square second square. So maka-cancel yung meter. Usa na lang ka meter diri and then second square and second square maka-cancel out. So we have what's left, Newton meter. So work and energy, they have the same unit. How about for the English? So for the English, so ang weight is in pounds, gravity is foot per second square, and then for the velocity, feet square second square. So ma-cancel sa second square, cancel lang sa ka foot. So what's left is foot pound lang gihapon. Okay? So be consistent, no, with your kanang unit. So mo na siya ang unit for the work and energy. Now, work is not a vector quantity, no? Work is a scalar quantity. So ngano man. So work is a dot product. So dili siya ingon nga cross product. So the result of a dot product, no, although that product is a product of kanang two vectors, but the resulting vector is not a vector anymore, but a scalar na siya. Scalar quantity na siya. So mo siya nahitabo sa work. Although ang mga components ni work, no, by its formula, work equals force times displacement. Force is a vector quantity. Displacement is also a vector quantity. However, if you perform that product, no, gikan ni sa inyo physics, I hope nga gitudluan mo ni that product. So ang answer ani is not a vector quantity, no, but kanang kuan, a scalar quantity, unlike the force. So ang force is a product of mass and acceleration. So mass is a scalar quantity. but acceleration is a vector. So nag-multiply ta, the resulting form is still a vector. So that is why force is a vector. However, for work, that product man ang hitabo. So for that product, the answer is a scalar, no? Meaning wala siya direction, no? Regardless of direction, it has a magnitude only. However, na inyo makitaan nga kuan nga na ay negative nga work. So ato na siya explore kung say pasabot sa negative nga work o positive nga work. Again, for work, iliingon nga ang negative nga work is towards the left and then ang positive nga work kay towards the right. So wrong na siya nga wrong na siya nga kanang assumption. So na explanation ni ana unsa equivalent anang negative work and positive work. So ato na siya explain later on. So the force vector should always be parallel to the displacement vector and vice versa. So mo gini inyong hinumduman for work because kung ang force is not parallel to the displacement, therefore you cannot generate work. It should be parallel. If it is perpendicular, then there is no work that is being done, no? Kailangan parallel siya. So natay illustration diri So we have here a block that rests on the inclined plane at an angle of theta. And then let's say nag-apply ta og force nga parallel to the horizontal surface, no? But not on the inclined plane, paana lang siya. And then we want to move this block up the inclined plane by the displacement s as shown in this figure. And then we need to resolve the force P because again, the direction or the line of action of our force is not parallel to the line of action of our displacement. Remember, our displacement is parallel to the inclined plane. However, our line of action of our force P is not parallel to the inclined, no? Naka-angle siya. So that is why we need to resolve this force P in terms of its component normal to the inclined plane as shown, and then parallel to the inclined plane by an angle theta, no? So with this, ang component ni force P parallel to the inclined plane is equivalent to P cosine theta. And then with this, so naanatay component ni force P which is already parallel to the displacement. So therefore, kanira day ang makado og work. While the normal component does not do any work at all in our block. So only kanang parallel component of the force P, no, ang maka-cause og work sa ato ang block. That is why the formula for work again is the force, and that force is equal to P cosine theta. And since ni-agree naman siya sa atong statement nga that should be parallel to the displacement, so mo ng P cosine theta and our displacement S. However, in this particular figure, it is not only limited to this formula. We can still modify this formula, no? There's another way to solve or to analyze this one. So na-put ay figure on the right, a similar figure. And then of course, similar gapon nga applied force P. And then we want to know the magnitude of the work as this block displaces S, no? So maniya ang displacement S from the initial position. Now, instead of the P, no, ang atong ikaduha nga pamaagi is that we want to align the displacement vector, no, this one, we want to align the displacement vector to the line of action of our force P. Ang atong force P horizontal. So pwede pud ta magkuha og horizontal component sa ato ang displacement, no? So if we resolve our displacement into components along the horizontal and along the vertical, so mo na yang horizontal, mo po na yang vertical, no? So ang angle between the displacement vector S and the horizontal is theta, no? Similar to this one, theta below. Now, the horizontal component is S cosine theta, no? and then the vertical component is s sine theta, which is equal to the height, no? Depends upon uh, the uh, the magnitude of the displacement. So in this figure, no, so our force P is already parallel to the or to one of the components of our displacement, which is the horizontal component. So in this manner, we can already derive a formula for work because ni-agree naman siya sa ato ang statement nga the force vector should always be parallel to the displacement vector. We already have a displacement vector that is parallel to our force P, and that is its component vector along the horizontal, which is equal to s cosine theta, no? Pareha naman sila. So therefore, ang iyahang component sa displacement nga kanang vertical, wala na siya naka-affect sa magnitude sa work. Therefore, ang formula ani is the force P and then S cosine theta. So kaning duha equal ra gyud na siya. So it depends upon the way you analyze the problem. It could be you resolve the force so that one of its component will be aligned to our displacement vector, as you can see in the first figure or in the figure nga naa sa left, or pwede siguro ang displacement, no, or you can have the displacement, uh, you are going to resolve its component which is parallel to the applied force or perpendicular to it, and then multiply, no? So you can do either the left side or the left picture or the right picture nga pag-analyze sa work. Again, ang takeaway diriya is that the force vector should always be parallel to the displacement vector. Okay, so nata diriya sa gitawag og positive work and negative work. So the sign for the work does not indicate the direction of the application of the work. So it means another thing. So let's explore this. Take for example, we have a block that that moves along this inclined plane. So it has a weight, then napoy applied force P, and then of course due to the weight, and then since ni rest man siya on the inclined plane, so the inclined plane would also exert a normal force N. And let's assume that this inclined plane is not frictionless, so there is a frictional force F, no? And then let's assume that this block will move up the inclined plane. So therefore, always good in note nga the direction of the frictional force is opposite to the direction of motion for this system. So if we resolve the amount of work, no, generated by this block, so that is summation of kanang kuan forces along the x. So why is it nga x man? Because that is the direction of motion. So we don't have any work along the y-axis because the block does not move, no, along the y-axis. So only the x-axis. So that is why summation of forces along the x or along the direction of motion times the distance is equal to these forces. So let's identify kung unsay naka-cause og kanang work diri. So first is the one of the components of the force P, which is parallel to the inclined plane. So that is why we have here P cosine theta. Now don't forget, if we execute this summation of forces, kailangan pod mag quantag sign convention, no? So that is take positive if the force is acts in coherent or along the given direction of motion. So ang direction of motion is upwards man. So positive ang force ana kung pa-upward siya mi-act. So ang positive lang nga force nga mi-act ana is ang component ni force P. So mao siyang P cosine theta S. While the rest for the weight, so si weight na siya'y normal component and at the same time parallel component, no, which is parallel to the inclined plane, and the parallel component of the weight is equal to weight sine theta. So mo na siyang gibutang diri weight sine theta. Then negative siya, it's because opposite ang iyang pag-act, no? Opposite sa direction of motion. And the last one is the friction. So si friction, ni oppose pud siya sa direction of motion. That is why it takes the negative sign here, no? So the same lang ang displacement for every forces, no? Given. Now, for the positive work, gitawag na siya og ano, obviously positive work. And then when we say positive work, the other term also is the accelerating work, because this is responsible for moving the object upwards. So marag common sense naman, if that is a positive work, meaning you exert, no, you exert a force to the block in order to move it, in order to accelerate it along the direction of motion. So kung gusto ka nga to siya sa right, so imo siya itud padung sa right, and that is a positive work. Now, for this kanang two remaining work components, so these are kanang mga negative work ni sila, no? Kaning W sin theta, because ni oppose sila sa direction of motion, wa sila nitabang, no? Sila inooy nipugong sa pag move ani ato ang block. So that is why they are called negative work or retarding work, no? It is responsible for slowing down the object upwards. So ang kakuan na ani, if kanang positive, so it helps the object in moving towards the direction that it is heading, whereas the negative work or the retarding work is responsible for slowing down the object, no? So mara na siya positive, mutabang siya, but negative kay nga sign, it means that it retards the motion of an object. Okay, so naka-follow ra class? Wala may pangutana so far? Wala ra? Okay, so continue ta. Application of the work energy method for constant force. So, kay bawo naman ta sa concepts for work and energy. Now, asa mi na to siya pwede i-apply for dynamics. So, we have here a statement, no? If a body is subjected to different set of forces during different phases of its motion, so the resultant work summed up for all these phases can be equated directly to the total change in kinetic energy. So, para ma-visualize ninyo, let's have some illustrations, no? So, first, we have here a car na ni-travel siya una sa inclined plane tapos sa horizontal nga plane. So, naatay mga kuan ani, assume nato nga atong car kay naay mga forces nga nag-interact niya, but dili lang na or wala lang nako ibutang diri no? Of course, na siya weight, then naay friction sa between sa tires and the road, no? And the thrust force generated via its engine, no, as it moves. So naa siya mga different set of forces, and then unsay pasabot aning different phases of its motion. So meaning it undergoes kanang several motions, no, or nag-change ang iyahang velocity baka or acceleration. So let's explore that one. So at ilet nga in this position mo na siya ang iyahang initial position at gi-label as 0, no? At 0 position. And then at the initial position, to assume nga na siya initial velocity, so nagdagan siya. And then after that, so ni travel siya via a displacement S1, and then miabot siya kaning pag-transition na sa incline to horizontal. So ato na siya consider nga this is the second position. So in the second position, ni change na iya velocity. So meaning lahi na po na siya nga phase of motion. So in the first position, so this is not the initial position na. So in the first position, V1 mo na siya iya velocity. So i-change na iya velocity from V0 to V1. And then after that, ni travel na pod siya along the horizontal, another phase of motion. So na po siya displacement nga S2, and then let's consider this one nga the second, no, second point. So we have 0th point, first point, second point of motion. And of course, it also has a final velocity. So, between 0 and 1, of course, naapod tay acceleration dira, wala na akong gisuwat. And also from 1 to 2, na tay acceleration. Now, if we're going to use our method that we have used from the previous nga lesson, of course, moagi pa gyud ta, no? Moagi pa tag 0 to 1, napay mga accelerations dira, mag-take pa tag FBD. We considered all the internal forces. We sum up all those forces, and then after that, proceed na punta from 1 to 2, no? We cannot go directly to point 2 without undergoing some analysis from 0 to 1 and 1 to 2. So ing ana to atong gibuhat sa previous nga mga lessons. But here, even if ni undergo siya of different phases of motion, but by using work and energy, pwede ra siya, no, i-sum up ang tanang mga forces and then equate din sa iyahang kinetic energy. Simple as that. So ato siya i-explore, no. So again, sa first phase niya, so niagi siya ni inclined plane, and this is its axis, no. So naka-inclined si x, and then si y is normal to this inclined plane. And then if we do summation of work here, so kanilang summation of forces along x1 nga axis times the initial displacement is just equal to the change in its kinetic energy. So from initial position na siya v naught square, no, na siya initial velocity v naught, so squared na minus sa final. Okay, so again, ang formula for kinetic energy is final velocity squared minus initial velocity squared. So equate lang. And then next, sa second phase of motion, mo na sa ni ato ang new nga axis, no. So our x component kay naka horizontal na, y component is naka vertical na. Now if we sum up the amount of work that is being done by this car from point 1 to 2, mo po ni ang nahitabo. So summation of forces along the axis x2 times the displacement s2 equals 1/2 wg. So this is the kinetic energy from point 1 to point 2. So from point 1 to point 2, ang final na po na nga velocity is v2. The initial velocity at this moment is v1 na sad. So mo nang v2 squared minus v1 square. So now, kani siya, pwede ni siya ma-simplify ning kaning duha ka equation, no? Wherein ato i-add ning duha ka mga work, that is work done from 0 to 1, ato i-add pod sa work done from 1 to 2, so that di na ta mag-mind sa kaning middle niya, no? Di na ta mag-mind ani nga part, only the initial gyud, that is point 0, and then final na lang point 2, no? Para mas mo pa mubo ang ato ang solution, unlike sa atong gibuhat sa kadtong previous nga mga lessons nga di kita pwede nga mo skip, kailangan mag FBD ta from initial state, then next i-connect na pud sa saka object, and then the final. So ingana atong gibuhat, but here pwede na to ma-derive nga mag-summation of forces lang. So if we combine these two equations, so adding the two equations, so i-add lang, summation fx1 s1 plus summation fx2 s2 is equal to the integral of this one. So again, summation and integration are kind of related man. So another notation lang ni siya ay kalibog ni ani. So if imon siya i-add, ma-eliminate ni siya, no? Ma-eliminate ang v1 squared o negative v1 squared. Mao na ang nahabilin is the final position minus the initial velocity, no? Final velocity minus initial velocity. So even if, no, along the way naa siya mga phases of motion nga naagian, basig nihunong na pud siya or naay lubak-lubak, as long as continuous ang motion, so what you need to do is that kanang you only take into account the final velocity and the initial velocity. So di na ka mag unsay acceleration niya in between, no? Ingani ni siya ka mubo og ka-compress ang kanisiyang work energy nga method. So ato i-compare to ato ang previous nga method nga gi-employ. So ang kato atong gigamit katong sa gikan pa lang gyud sa kinetics of rectilinear translation, niagi po ta og kinetics of curvilinear translation, and also kinetics of rotational motion, and also the kinetics of plane motion. Ang atong method nga gigamit is the force inertia method, no? Force inertia method. Kaning force inertia method na siya advantages, na pud siya disadvantages. So ato ni siya i-compare kaning work energy method o force inertia method. So let's compare these two by the principle, no, nga ilang gipanggamit. So first, si force inertia method ta. So kay bao naman tani, it uses the principles of kinematic and kinetic equations of motion. So remember this one sa atong discussion sa previous. So nag-summation of forces ta is equals to the resultant force, and then sa x-axis ni siya, and then at the same time naputay y-axis kay 2D plane man ang ato ang gi-analyze, and then we also have summation of moment, no, along a center of rotation, no, along a center of gravity. So it depends kung centroidal moment at the center of gravity. So mass moment of inertia times alpha. Mo ni ang gini ang mga formulas nga gigamit for force inertia. And then ang nakakuha sa force inertia, mag-create og mga FBDs sa tanang mga objects nga present in the system, no, as is very desirable gid kaayo kay para hibaw gid ta sa mga velocities and acceleration. However, for the work energy method, lahi ang iyahang kanang principle nga gigamit. So ang work energy theorem, no, mao to siya kato atong giderive kaniha. Summation of force times distance equals the kinetic energy equation. Now sa work and energy method nagyapoy FBD, pero mag-apply ra siya, it depends upon the object of interest. So kung single object ra gali, usara. Kung system of kanang bodies, so assume nga connected sila, no, together, so kana ra pod, pero nay ma-eliminate ana, no, so ato i-explore naay ma-eliminate nga mga forces nga nasa FBD for the work and energy method. So daghay matangtang ato mao nang mas kanang comfortable siya gamiton. Okay, let's say for example this one, no, effects of internal force system. So considered nga naa ta diri ay kanang kuan block, no, na ni-rest on the table or on the horizontal surface, while the other is suspended lang. So assume ta nga bugat ning nakasuspend nga block, no. So for work energy method, the tension of the link is neglected in the calculation. So di ba sa ato ang force inertia, ato gyud ni siya indicate ning mga tension sa kanang link nila, di ba? So kani nga link, this is a chord, no? A chord type of link. So ato gyud na siya indicate. However, for the work energy, pwede na siya tangtangon. So ngano man? So ato i-explore. So let's say this block has a weight W1 and then 9 normal force, and then na siya tension. Assuming nga frictionless ni siya. Aw, didi ay naman ko gibutan din nga force. So naay friction, and then ang kaning naka-suspend nga block, so na siya tension, and then I work number 2. Now if we let nga kani siya ato ang block kay ma-carried out siya towards the right, and then kani pud ato ang naka-hang block mo move downward. So for block 1, magkuan ta dira apply ta sa work and energy or work energy theorem. So mahimo siyang summation of forces along x1 times s equals, so unsa may mga forces nga parallel sa atong direction of motion. So we have tension and the friction only. Si normal force og si weight wala nganuman. They are perpendicular to the direction of motion. So wala siya naka-cause of work, only tension and force. So equal to 1/2 Wg delta V1 square. So V1 indicates the first thing object, no. So let's proceed for block number 2. So for block number 2, summation of force times distance sa gapon. So this time kaning duha, si tension og si weight sa block number 2 are responsible for the work. So positive si weight 2 tungod kay along man siya sa direction of motion, then negative ang ato ang tension. Now, if we're going to add these two equations, what will happen? So gi-add na ilang mga forces times displacement nahitabo plus TS minus TS. So bali ma-zero ra. So mao nang kung mag-solve mo og mga system of rigid bodies and they are connected via a link, it could be a cord or a wire rope or a chain or sa baka na dira. So ang ilahang tension no ma-cancel out ra ang work because ang internal forces ang nagni-act ni ani ang tension kay they are opposite to each other no. So paraan ni ang tension from block 1 kay towards the right whereas kaning tension from the hanging block kay upward siya. So magsugat sila mo ng ang ilang amount of work ma-cancel out with each other. Mao nang sa pag FBD for work energy method, just ignore na lang sa kaning effects sa tension. Then ang usage. So sa usage, si force inertia method requires a lengthy process of evaluating the motion of a particle. No? However, importante gihapon ni siya. So indispensable gihapon siya in determining the instantaneous acceleration caused by the variable forces or moments. Now kung gusto gyud ka makahibaw sa acceleration at a particular time sa usa ka rigid body system, gamit gyud gihapon si force inertia method. Ang iya lang gyud taas kay proseso. But kung gusto kag ang pangitaon ra kay ang mga velocity ra sa final position, then go for work energy method because it will usually be faster and easier than force inertia method developed in the previous lessons. So inyo ni siya makuan karon kay ang ako ihatag nga example diriya is kato atong mga na-solve before nga taas kayo and then for the work energy method mas mubo na siya no. So the general plan for applying work energy method, first kailangan i-determine sa nimo ang direction of motion. So mao ginay una because that would tell you kung positive ba ang work na generate or negative ba. And that would also tell you kung sa pag-resolve og mga forces nga naka-incline siya no with respect to the axis of the direction of motion. And the next confirmation is obtained by noting that the resultant work must be positive to speed up a system. So if that force helps to speed up the system, then positive ang kana siya nga work. But if that is a friction, so si friction gyud always gina siya kan gina siya ang friction kanang retarding work gina siya because si friction is always opposite to the direction of motion. So that is why siya may magpugong, so negative work na siya, meaning it slows down the motion of an object. And then next, determine the kinematic relations between bodies composing the system. So labi na ni for system of rigid bodies like na ay mga blocks nga connected by a cord and then that cord will kanang muagi siya og pulley. So imo sa kitaon kung ang displacement sa usa ka block is equivalent ra ba sa displacement on the other block basin og ang displacement sa usa ka block no is not equal to the other block na connected niya. It could be half lang or 2 times or 3 times so on and so forth. So kailangan imo pud na siya i-determine. The third one, so after determining the direction and the kinematic relations, proceed din ka no. Apply dayon sa kato-ato ang general equation for the work and energy. And the fourth one, if the internal force in a connecting member is desired, so mo na to no. I-neglect na lang to kay syempre ma-cancel out man tong mga tensions no. So apply the work energy equation to a free body diagram of that part of the system on which this force then acts as an external force. So if the internal force is not constant, however, this step will determine only its average value. So if dili to constant no, so again kato ato ang or kato ako ang gipakita sa inyo kaganiha, mo-apply na to siya if constant ang katong tension, no? So, kanang assumption, valid na siya if ang ato ang cord kay dili siya mo stretch, no? Di siya elastic, no? Pero og elastic na gali, so mag-vary na ang magnitude sa atong tension sa ato ang link. So therefore, with that, mas maayog mo gamit alang ka og force inertia nga method, no? To know the instantaneous value of a variable force or the acceleration. Okay, so we have, let's have the first problem. So this is the problem statement. The 300-pound block in the figure rests upon a level plane for which the coefficient of kinetic friction is 0.2. So find the velocity daw of the block after it moves 80 feet starting from rest. So if the 100-pound force is then removed, how much farther daw will it travel? Okay? So again, kung may problem, isulat ang given, no? So the given, we have the weight of the block, 300 pounds, the applied force, 100 pounds, the angle between the applied force and the horizontal axis is 30 degrees, and then kinetic friction coefficient 0.2. Then we have an initial displacement S1 80 feet, and then since gi-state sa problem nga starting from rest, so the initial velocity of our block is equal to 0 feet per second. So the requirement, I think we have two requirements. So first is the velocity of the block after traveling 80 feet. So that is V1, no? Not V2 because nag-start mo ta sa V0 or the initial position. So V1 na ang next position. Then S2, that is the second displacement. Okay, gi-statement diri displacement for the block without the 100-pound force. So how much further daw will it travel, no? Kung i-remove na ato ang 100-pound force. Gi-statement dira. Okay? Una buhaton, mag-FBD ta. So, naay duha ka phases of motion ang nahitabo ani. First is pag-travel niya og 80 feet. The second one is ang pag-remove sa katong 100 pounds nga force. So, ato sa i-analyze ang first phase of motion so that we can solve for its velocity after traveling 80 feet. So, this is our object. So, ang mga force nga nag-act, we have the weight downward, the normal force, and then this is the direction of motion that is towards the right. So, it is understood that direction of our kinetic friction is towards the left, no? Ni oppose siya. Now, kung inyong manotice sa atong FBD, ang color sa arrow for our weight and the normal force is gray. So, ako siya gituyo so that inyong ma-visualize nga ang weight ug ang normal force dili na siya maka-affect sa ato ang work because the weight and the normal force acts perpendicular to the direction of motion, not parallel. So, ang only forces nga maka-cause og work is the applied force, but take note, si applied force kay naka-angle siya. So, you need to resolve its component nga only parallel to the direction of motion. And then, the second one is the frictional force, F1. Now, we cannot solve for the frictional force without solving the normal force. So, I think the first solution is we take summation along the horizontal, along the vertical. So, we take summation of forces along vertical, that is equal to 0. So, that is, we take positive kung upward siya. So, ang upward force na to, we have the normal force. And then, naputay component ni applied force, no? Ang kaning 100 pounds naman siya ay vertical component nga upward. And that is P sine 30, no? Or that is plus 100 sine 30 degrees. And that is equal to the weight because the weight is downward man siya, no? that is equal to W. Our weight is 300 pounds, no? So therefore, the normal force is equal to the weight is 300 and then minus 100 sine of 30. So therefore, the normal force ato i-calculate. So 300 minus 100 sine 30. The result is 250. So 250 pounds. Therefore, our F1 equals mu k n, or that is zero point 0.2 times 250. So that is 50 pounds, no? Okay, 25 times zero point 0.2, that is 50. So 50 pounds ang ato ang frictional force. So na naman tayo value sa frictional force, then we can use our work and energy equation. So our work and energy equation, that is a summation of the force along x times the displacement, that is S1, is equal to 1/2 the weight over g and then the change in the velocity. So that is v1 squared minus v0 squared. Okay? So summation of forces, that is we take positive if towards the right, tana? So ang mga forces nga ni-act towards the right, we have one of the components of our 100 pounds nga applied force. So that is 100 cosine of 30 and then S1 minus F1 times the displacement S1. No, same lang gihapon, is equal to 1/2 WG tapos V1 squared minus 0. Why 0? Because the initial velocity is 0. No? So, solving for V1 square, so we have V1 is equal to, so, square root ni siya, meaning kaning sa left side, ato isuwat ang una, so we have 100 cosine 30 degrees. S1, so the first displacement is 80 feet, so times 80, minus the frictional force is 50 times 80 divided by, so kaning 1/2 WG. So we have 1/2, the weight is 300, G is 32.2. So pila man ang ato ang initial velocity. I mean, velocity at point 1, not the initial di. So we have, factor out man ang 80, no? So 80 tapos 100 cosine of 30 minus 50, then divide by 0.5 times 300 divided by 32.2. Okay, the result is 25.07 or 25.1. So 25.1, this is feet per second. Ay, sorry, only feet per second kay di man din siya acceleration. So feet per second. So this is the velocity of our block as it travels 80 feet from its initial position. Next, okay, I forgot to put the ID, the kan the axis. So muna siya ang notation sa axis niya. Okay, so next, FBD of the block. So second phase of motion na. So meaning in the second phase of motion, gi-remove na ang 100 pounds nga applied force. So ang atong FBD mahimo lang og weight, then nagyapon normal force, and of course nidagan gyapon ni siya even if nawa na ang force. So syempre nagdagan naman siya, no? Ang iyagon velocity after 80 feet is 25.1. So bisag ato gi-remove, di magina ang object nga mo kuan dayon, mo stop dayon. So napa na siya na sustain nga energy so that makapatravel pa siya before pa siya mohunong, no? So mao na pa siya direction of motion towards the right. And then ang opposing force gihapon is the kinetic, the friction, no? Frictional force. So again, ato gihapon butangan o ganang label for its axis. So our new axis is x2 na, that is for the second phase of motion. So here, ang atong value for the normal force mag-change na because wala na tay applied force. So we take again summation of force along the vertical, that is equal to 0. Positive siya is if upwards. So our normal force, let's say 2 lang ni siya, no, for the second phase. So I forgot to change this one. This is 2. So N2 equals the weight, and that is equal to 300 pounds. So therefore, our frictional force for the second phase is the product of mu k and N2, and that is 0.2 times 300, and that is equivalent to 60 pounds. So by comparison, sa first phase nga naay applied force nga 100 pounds, gamay ra ang frictional force. Pero pag remove na gali ni dako na kay wa na may nag counteract sa ato ang frictional force, no, manang ni dako iya ha value. So with this, again, using the work and energy equation, so we have summation of force along x2 times s2 is equal to 1/2 wg. So this time ato iko gikan si block ani nga mga points. So we have initial position, first position, and then the second position. So naanta diri nanata diri sa S2 nga part. So therefore ang ato ang final velocity ani is v2. So v2 squared minus the initial na ani is kaning v1. So v1 squared. Okay. So we take positive if towards the right siya. Now, usara ka force ang naa, only the frictional force, and towards the left pa gyud siya. So manang negative ato ibutang because retarding work man siya. So we have negative F2 S2 equals 1/2 Wg tapos V2 squared minus V1 squared. Now, at point 2, no, ni come to rest na siya. Although wala gi-state sa problem, no? Pero may makakuan man nimo, ma-analyze nimo ginsakto nga how much farther will it travel. So like pagka wala sa applied force, so mudagan siya, and due to the friction, no, kay naa may friction nga present, so muhunong gid siya, no? Mao ingon nga unsa pa siya kalay-a nga mo dagan nga ato na magikuha ang 100 pound nga force. So therefore, ang ato ang final velocity ana is mag-zero na, meaning ni come to rest na siya. So therefore, our V2 is equal to 0. Okay, ni come to rest naman siya. So mahimo ning negative F2 S2 equals 1/2 Wg, and then negative V1 square. So na may negative on both sides, no? Pwede multiply by negative. So that is why our S2 is equal to 1/2 Wg, then V1 squared all over F2. So plug in the values. We have 1/2 tapos 300 over 32.2, and then our V1 ato naman na solve, that is 25.1 square, and then over the frictional force 60. So pila ang ato ang displacement 2. So we have 0.5, 300 divided by 32.2, and then we have 25.1 square over 60. So the answer is 48.91. So 48.9 na lang, then this is feet. So therefore, pagkuha nato sa applied force nga 100 pounds, naka-travel pa din siya og 48.9 feet. Tugod din siya sa iyahang na-sustain nga kinetic energy, kay ang iyahang velocity is 25.1, pero tungod kay gikuha na ang 100 pounds nga force, so therefore nihinay-hinay nag-reduce iyang velocity. So naa nay deceleration nga nahitabo. Hangtod nga na zero na gyud iyahang final velocity at point 2. So inganin siya pag-interpret ang ato ang problem. Okay, nay pangutana ni class so far? How about the others? Okay, naay ni raise og hand or na ni chat? Okay, sige. Oo, sa tension, sige. Oo, makancel, oo, makancel. Nako example diri nga bisan pa og um napay usa ka pulley tapos duha ka cord tapos usa ra ang naa ngadto, makancel gihapon sa kuan pag-analyze. So mao ni naka-advantage ni ani sa pag duha pa ka duha pa ka cord ang naka-connect niya, so ma-cancel out ra gihapon. Oo. Okay? So proceed ta sa second problem. So problem number 2, after the 100 pounds block in the figure has moved 10 feet from rest, so the constant force P is removed. So similar lang siya no sa atong first problem, but here naka-inclined lang. So find the velocity of the block when it returns to its initial position. Pero naan la i-catch kay i-analyze mo nimo no kay ni-return na siya from its initial position. So yun sa kani pag-visualize. So given nato the weight of the given block 100 pounds, the applied force P 120 pounds, and this is parallel to the inclined plane. Wait lang class, wait lang. Okay, so balik ta. And then we also have the initial displacement no S1 10 feet, and then the given coefficient of friction that is 0.2. This is kinetic friction. So again, kinetic friction gini siya kay nag-move naman ito ang block. And then since gi-state sa problem nga from rest man no. So starting from rest, so initial velocity of the block is 0. The requirements, okay, we only have one requirement for this, that is the velocity of the block when it returns to its initial position. And then I label this one as V3. So ato kitaon, meaning niabot data og 0.3 ani no. So ato na ni siya kitaon nganong na 0.3 ni siya. Wait lang. Okay, continue ta. So first, mag FB dita no for the block. And let's start for its first phase of motion. Actually, na ay tulo ka phases of motion ang nahitabo ni ani. So ato i-explore. Part po ni siya sa inyohang pag-analyze. So first phase is ni travel siya from rest, no? Gikan siya from rest, and then ni travel siya by 80 80 ba to, or that is 10, sorry. Okay, 10 feet. Okay. So 10 feet from rest. So for the FBD of our block, so ato i-label as 0 siya for its initial position. And then naatay weight nga ni-act sa tong block, and then ako na siya gi-resolve no by its component normal to the inclined plane and parallel to the inclined plane. So we have W cosine theta, W sine theta. Now ako na pud gituyo nga gray ni ang ato ang normal component because wala ni siya maka-cause og work, no? Wala siya naka-contribute sa work because the direction of motion ani is parallel to the inclined plane. The next, we have given applied force P up the inclined plane iya direction, and then natay normal force na at the same time the frictional force, but unya na lang. So at sa ikuan nga ang kaniya ang block mi-move ni siya no via displacement of S1 that is equal to 10 feet. So man iyahang second position, and that is labeled as point 1, no? So the direction of motion is up the inclined plane, so that is from point 0 to point 1. So if this is the direction of motion, it is understood that the direction of the frictional force is opposite, so man towards the left siya, no? Bottom left. Okay, so by having this one, makasolve ta sa iyahang velocity at point 1. But before that, no, need man nato sa work and energy nga equation ang value sa frictional force. So before having the work and energy equation, dapat we take summation first, no, nga normal siya sa to ang inclined plane. Normal to our inclined plane. So we take summation of force that is normal to the inclined plane. That is equal to 0. So positive siya if kuan siya, pa-upward siya sa ato ang inclined plane. So ang naarad nato is the normal force, that is equal to W cosine of theta. The given weight is 100 pounds. So 100, and then for this type of kanang angle representation, so this is theta and then this is 5, so our cosine of theta is equal to 4/5, no? 4/5 na siya. So 100 times 4/5. So that is 20 times 4, so that is 80. No, 80 pounds. Okay, so mana siya ang value sa ato ang kwan, atong normal force, no? So next is ang iya frictional force. So therefore, the frictional force is equal to mu k times the normal force, so that is 0.2 times 80, so that is 16, no? 16. So we have 16 pounds. Okay. So next is magkuha na ta. Ato to gamit itong work energy nga equation. So for the work energy equation, summation of forces that is along the incline, no? So ato lang ikuan nga this is our, I forgot to put that. This is our x-axis. So ato lang x1 na. And this is our y-axis, y1. So therefore ato lang less than y1. So that is summation of force x1 then s1 is equal to 1/2 wg, and this is v1 square minus the initial square. Okay, so we take positive if kana siya nga work is moak siya, or ang force, no, is moak siya up the inclined plane. So unsa man ani nga force, so only the applied force P, the rest kaning W sine theta and F opposing sila, so mo retard sila. So therefore we have P S1 minus F S1 minus W sine theta S1. Balik distribute na nako daan ang ang displacement, no? And that is equal to 1/2 Wg, then V1 square minus V naught square. Remember, starting from rest, so V naught is equal to 0 na siya. So therefore, our V1 is equal to the square root, no? We can factor out S1, then P minus F minus W sine theta, then over 0.5 or 1/2, same na siya, Wg. So plug in the values. First displacement is 10 feet. So 10 times the applied force is 120 minus frictional force 60. I mean 16, sorry. This is 16. Minus the weight is 100. So 100 and then sine theta. Okay. Naman dito value for sine theta, no? So again, sine theta, the figure that is 3/5. So we have 100 times 3/5, na close parenthesis, divide by 0.5 times 100 over 32.2. Okay? So our V1, ato i-solve. So square root 10 times 120 minus 16 minus 100 times 3/5, and then 0.5 times 100 all over 32.2. So the answer is 16.83. So 16.83, this is feet per second. So this is our velocity at the second kanang position, or that is 0.1. So next ani, ngadto ta sa second phase of its motion. So di pa na mao ang velocity niya sa pagbalik niya at 0.0. So remember, musaka pa daw ni siya, no? So ang first phase is musaka siya by 10 feet, and then kuhaon na pud ang force P. So di na ingon nga mohunong din ha. Napa man na siya kinetic energy. So mupadayon pa na siya hangtod nga mo decelerate siya mo zero. And tungod kay inclined plane man ni, so mudanlas na pud siya pabalik sa ubos hantod makaabot siya sa kaniya initial position. So mao nang we have three phases of motion, no? So next ani, so from 1 to kuan pud ta, from 1 to 2, no? So from 1 to 2. Siguro na mga tanong sa inyo, sir, nganong nag-agi-agi man ta mga phases, nganong di man ta mo diretso sa initial and then to final. Now, ang problema diriya is wala tay enough information to do that because nahitabo man gud sa atoang system, no? Wala tay displacement gikan sa initial position padong sa misaka siya insakto, no, sa maximum height and then mobalik. So wa man tay enough ana nga information mao nang gibay phase nato, no, gibay phase nato. But there are some problems nga na given nga mga displacement, so kana siya makuha din na siya right away by considering only the extreme phases, no, the initial and the final position. But here ang analysis for um, each phase is very crucial. So proceed ta sa second phase. Now for the second phase, ang FBD niya nalahi na. Unsa may nawagtang class, unsa may nawagtang sa second phase of motion? Hello? Naka-follow pa? Ang friction nawagtang? Ang friction ba? Unsa man ang friction na wagtang or nailain na wagtang? Kay ang applied force kay gi-state man sa problem nga gi-remove ang applied force. So unsay mahitabo niani? Now pag remove sa applied force again, napo na siya enough nga energy nga mosaka. Di na ingon nga hunong dayon siya pagkuha nimo sa applied force niya mobalik paubos dili. So napaman siya velocity. So mo keep on going pa na siya upwards until mo reach siya sa point 2 wherein sa point 2 hunong na gid siya. So mo nang nanapot information for the velocity at point 2 and that is equal to 0 kani hunong naman siya. So mao nang ato ning pangitaon ning pila iyahang displacement after gi-remove ang ato ang force P. So mo na itong pangitaon for the second phase. So with this, we cannot use the value of the normal force from the previous FBD because dili sila equal no tungod kinatangtang ang force P. Oh, I think murag equal na gyapon, sorry. So equal gyapon even if natangtang ang force P because if you take summation balik no at the normal axis. So let's say mo ni siya to ang mga axis no. This is x2. This is y2. So if you take summation of forces along y2, ato lagi po isuwat bisag although nahumanan sa tala isuwat no. Forces along y2 that's equal to 0. So we take positive if paana siya. So therefore the normal force is still equal sa weight cosine of theta and that is equal to 100 times 4/5. No, kay ba naman na 4/5 kay mo ang theta. So 4 then 5 na siya. So 4/5 and that is equal to 80 pounds. Okay. So after this, perform dayon, o pa day, ang force, ang frictional force pa day. So frictional force is mu Sn, so 0.2, and then 80, so that is 16 pounds. So human ani, work energy dayon nga equation. So summation of the product of the force along x2 and its corresponding displacement s2 is equal to 1/2 Wg and then ang final na ani since ang ato ang point of interest kay from point 1 to point 2 so ang final ani is point 2. So manang V2 squared minus V1 squared. Okay. So we take positive if kana nga force kay acting up the inclined plane, no, parallel the inclined plane. So kay ang duha man pulos man paubos so pulos na siya negative. So we have negative W sine theta minus F S2. I forgot S2 area. That is equal to 1/2 Wg and then V2 square minus V1 square. So ang V2 nato equal to 0 no at max niya nga height no nga ma-reach niya before pa siya mo fall back sa initial position. So V2 nato 0, then we already solve for the value of our V1 no from the previous nga kanang slide that is equal to 16.83. So with this, we can also multiply both sides by -1 para positive tanan and then solve for S2. So we can factor out S2 here, no? Mahimo siya S2 W sine theta plus F is equal to 1/2 Wg and then V1 squared. So our S2 is therefore 1/2 Wg V1 squared over W. Our sine theta is 3/5 na. So W 3/5 plus F. So plug in the values. We have 0.5. The weight is 100 over 32.2. And then ang V1 nga itong nakuha sa previous slide, that is 16.83. So 16.83 square. Then divided by the weight that is 100 times 3/5 plus the frictional force 16. So pila man ato ang S2. So we have here 0.5 times 100 divided by 32.2. Then we have 16.83 square. And then 100 times 3/5 plus 16. So we have 5.79 na lang ato ibutang. So 5.79, this is feet. So naka-travel pa din siya og 5.79 feet before pa siya miligid pa ubos, no? So ato po ni gamiton si S2 so that we can solve for the velocity, no, of this block pag return niya sa iyang initial position. So FBD, this is not second phase. I forgot to edit this one. So third phase na ni siya. Third phase of the motion. So nahitabo na nata sa point 2, no, sa max height niya. So again, the velocity here, V2 is 0. Mo ni ang FBD nato. So unsa ray nalahi diri a class? Unsa may nalahi diri a? Okay, ang motion. Unsa may nyo na-notice sa direction sa frictional force? Okay, baliktad na siya sa motion again. Ang motion nato diri di na pasaka, no? Paubos na siya kay birahon man siya, no? Down the inclined plane. So pangadto na from 2 to 3. So therefore, ang ato ang parallel component of our weight nakatabang na siya. So di na siya retarding work ani this time. So positive work na siya. Only the frictional force ang retarding work diri a. Okay? So with this, we take summation of force, no? At butang na itong axis ani. So this is x3, then y3. So along y3 equals 0. So positive if upward. So therefore, parehara gyapon, no? Normal force W cosine theta, or that is equal to 80 pounds. Ako lay lahos. And then the frictional force, that is mu Sn, so that is equal to 16 pounds. No, maramang gihapon nga nao nga. So diri proceed dayon ta sa work energy equation. So summation of force along x3 times the distance s3, no? So times the distance s3 is equal to 1/2 wg, and then since ato ang point of interest is from point 2 to 3, so ang final nato is v3. So v3 squared minus v2 squared. Now, our S3 is the distance from point 2 to 3, and that is the sum of S1 plus S2, no? That is S1 plus S2. Our S1 is 10 feet. Our S2, ato nakuha sa previous slide, that is 5.79. So therefore, we have 15.79 feet. Mo na ang distance from point 2 to 3. Okay. Then, kay baw po that at point 2, ang atong velocity ana is 0 because naghunong man siya dira at maximum height. So with this information, we're going to solve for V3. So V2 here is 0 na siya. So V3 is equal to the square root. So kaning summation of forces along x3, we take positive di if, again, this time going downward na, no? Di going upward, so going downward. Therefore, W sin theta ang positive, si frictional force negative ni siya. So buta lang diri S3 times. So we have W sin theta minus the frictional force all over 1/2 and then W over G. So substituting the values, S3 is 15.79. Then the weight is 100. So 100 and then sine of theta, that is 3/5. So this is our theta. No? So 3/5 atong sine theta. And then minus, ito ni-erase. So minus the frictional force, which is 16. Then divided by 0.5 times 100 divided by 32.2. So therefore, our velocity of the block, pagbalik niya siyang initial position, so ato gamitan sa itong calculator. So we have square root 15.79 times 100 times 3/5 minus 16 divided by 0.5 times 100 divided by 32.2. So we have a velocity of 21.15 or approximately 21.2. So 21.2 feet per second. So muna siya yung velocity pag return niya balik sa yung initial position. So mao na siya answer sa problems nga naa sa work and energy kana theorem. So nasa libro. Problem number 1405 na siya. So final answer is 21.2. So na yung pangutana ni class before we proceed to our final problem. Ha? Na yung pangutana? How about the others? Ang uban? Wala ra? Okay, proceed ta sa last nga problem for this meeting. So as shown in the figure, the 300 pounds counterweight B, so kaning block B, pulls the 200 pounds block A. So ang block A ni naaning nirest ano siyang inclined plane at an angle of 30 degrees. So the coefficient of kinetic friction sa kaning inclined plane is 0.2. So if the pulleys are considered frictionless and weightless, so datay duha ka pulley ani no kani. So pulley 1, pulley number 2. So determine daw the velocity of block A after it has moved 20 feet starting from rest. Okay? So kaning si A ni move daw. So since mas heavier man si block B, so magani ang direction sa motion, no? So move ni siya si A, ang displacement daw ni A is 20 feet. Kani siya ato ni siya na solve, no? Sa ato previous lesson. Pero kuti kaayo daghan tay mga summation of forces aning usa, kaning ring B, napigid ta ni consider pataning diri kaning usa ka pulley, no? Tungod kay matunga ba ang tension niya ni. Okay, but for the work and energy theorem, i-neglect na nimo ang mga tensions nga nag-connect aning duha ka block. Assuming nga di ni sila mo elongate, no? So di ni sila ma-deform mga tong cord, dili po din siya mo stretch. Mo na assumption. So ang given nato, we have the weight of block A, then we have the weight of block B, the displacement of A, that is 20 feet, then the kinetic friction of the inclined plane, and the initial velocity of A, that is 0 feet per second kay starting from rest man. So the requirement, I think usa lang, no? So we have only one requirement, that is the velocity of A after it has moved 20 feet. Okay. So we need to know the FBD of the entire system, no? Labi na kay naay mga links ni ani. So ato kitaon. So this is our system. Then ato pagitaan og FBD ang mga objects nga present. So we only have two objects here, block A and block B. So let's start with the block A. So this is our first object labeled 1. So naatay component sa iyahang weight. So normal sa atong inclined plane, that is WA cosine theta, and parallel to our inclined plane, which is WA sin theta, directed downward. And then napo tay normal force. And then this is the direction of motion. Mao nag-ingon nga birahon ni si block A, no? Since si block B kay bugat man, so birahon ni siya si block A pa upwards. Mao ang direction of motion. And since muna ang direction of motion, so understood that the frictional force is downward, no? Ni oppose siya sa direction of motion. And then the second object, mao po na iyang FBD. So the weight of the block B. And then walay tension. So again, sa first object, wala po ko nabutang tension diri sa FBD because i-ignore na lang nato for work energy nga method, no? Ignore na dira. But next, since na may mga pulley system, ang displacement sa A is not equal sa displacement sa B. Okay, aton siya i-verify. Now, kung mo displace niya atong A by an amount of SA, so displace siya. May tabuan ni. So tungod ani nga chord, no, katong i-discuss last nga kani siya mo tuyok pa ni siya og kaduha kung mo move ni siya diri og 1 unit downward. Okay? So remember, kani mo tuyok og kaduha, no, duha ka displacement. Now if this is x, syempre x pud ni. However, tuyok man ni. So duha ka x. So mao nang ang displacement sa A, ang corresponding displacement ana sa B is half lang, no? Half sa A kay again ang A is twice sa B. So in reverse, SB is half ni A. And in the same way, if we have a velocity of A, then ang corresponding velocity ni B, di sila pareha tungod aning nga pulley. Kung wala ni siya nga pulley, 1:1 ang ratio. But with this pulley, half ang ratio pod siya velocity. The same true with the displacement and also the acceleration. But acceleration diri is not of importance man kay wa man gipangita. So wala na ako gibutang. Only the displacement and the velocity. So by having this, then pwede na ta maka-perform og kanang kuan. Pwede na to magamit ang work energy nga equation. So for the work and energy equation, para madali or pwede po na to ibuwag-buwag lang. So mag-una lang ta sa kanang work energy for the first block, no, kaning block A. So for number 1, we have summation of forces, let's say along this axis, no, so ito na i-label mo na ito i-label ng axis. So this is x1, then y1, no, summation of forces along y1 data kay napamay friction. So that is equal to 0. Take positive if paana iya direction. So si normal force raman og si WA cosine theta ang naa. So normal force WA cosine of theta. Our theta is 30 degrees na siya, no? 30 degrees. So our weight ni block A is 200 pounds. So we have 200 pounds and then cosine of 30. The value of our normal force is therefore we have 200 cosine of 30. So that is 173. So 173 pounds. So therefore our frictional force is mu Sn. Our given kinetic friction is equal to 0.2 times 173. So times 0.2. So the result is 34.64. This is 34. Wait lang. 34.64 pounds. Okay, so next we are now ready um, to perform the work energy equation. So summation of the product of the force along x1 times S1. So our S1 here is equivalent to the displacement of block A. So that is SA equal to 1 half WA over G. And then we have the final velocity of A, that is VA square, minus the initial velocity of A, no? That is VA0 square. So we take positive if going upwards. So ang mga forces nga kanang pababaw, wala, paubos ra. So negative na siya. So therefore we have SA times negative, this is WA sine 30 degrees, then minus the frictional force, that is equal to 34.64, is equal to 1 half, then our WA over G, and then our VA square. Okay, we don't have VAO kay 0 naman na siya. Okay, so dira ato ikuan, ato kuhaon ang ato ang VA, no? Pero kay okay, I think pwede pod makuha si VA. Pwede ba makuha si VA? Okay, so I think as is lang siguro, no, ato lang ning i-add ning duha. So ato ning i-add ang duha. So as is lang sa ni siyang kaning ato ang first nga kuan kani siya, and then ato na siya i-add for the second kay ni happen mo ganun sila simultaneously, no? So next ni ini is ang ato ang kuan second nato nga kanang kuan object. So for the second object, usara man ni siya, no? So summation of the product of the force ato lang pod anaon diri iyahang kuan. So this is y2, this is x2. So sa x2 kay along siya sa direction of motion. So along man siya sa kanang direction of motion, so mahimo na siya og fx2, and then ang iya displacement dira is that is SB, no? SB. So may butang that is SB is equivalent or is equal to 1 half WB all over that is all over 2, all over G, and then ang iya diri is this is VB square minus VB0 square. But since both of them starts from rest, so therefore 0 na siya, no? So we take positive if going downward, downward na siya. So we have the weight of the block B. So WB, then that is equal to, or that is multiplied by SB, that is equal to 1 half WBG times VB square. Okay, so VB square na siya. Okay. So ang next ni ani, no, ang next ni ani is ato na siya i-combine sa first. So if we combine this one kani siya, no? So ang total man ano, ang total man nga work atong gikuan ani. So for number 3, combine summation of force x1 then SA plus summation of force x2 SB. So kung imo to i-sum up katong previous, so we take positive ni siya if along sa motion sa ato ang kuano, motion sa atong duha ka blocks. So ang motion sa atong duha ka blocks ato lay summarize as this one, ano no, mutaas siya tas paana. So kung along gayani, actually pwede pod mo kanan ani no, mo sana mo largo mo ani, pwede mo di mo magtagsa-tagsa, mo largo din mo sa pag-add, pwede ra gyud kaayo. So ako lang 'to gipakita para masabtan sa inyo. So diri we take positive kung ang force kay ingani iyahang iyang direction, no? So pataas paubos. So ang only force nga kanang positive for this diagram is only the weight of the block B, no? Kay kanira man tulo ato ang naka-cause of work. The weight of the block B, the frictional force, and one of the components of the weight of block A, no? So diri we have ato isuwat ang una, no, positive. So we have WB and then ato multiplyan sa iyahang displacement, no? Displacement niya is SB and then ato na siya i-minus nato sa kaning duha ka buok, no? So minus we have force, frictional force plus WA sine of theta times SA is equal to kuan pod, ato po i-add ilang mga kinetic energies. So we have 1/2 WA over G and then that is VA square plus 1/2 WB over G and then this is VB square. So ato i-solve diri is ang velocity ni A, no? The velocity for A. Now, ang given ani is ang ato ang kuan. Ang kuan ani, ang given ani kay ang kuan. Wait, ato pa rin siya i-kuan, no? Kaya naman tayo SB diri So ato ibutang but SB nato is equal to 1/2 of SA. And then our velocity B is equal to 1/2 pod of velocity A. So diri this is WB 1/2 SA minus F plus WA, this is sine theta. Then we have SA is equal to 1/2. This is 1/2 WA over G. Then this is VA square plus 1/2 WB over G. And then our VB is 1/2 VA, so that is 1/2 VA, that is square. Now, ang given sa problem is not the displacement of block A, but the displacement of the block B, no? So, ay mo kalibog sa statement dira, ano, problem statement, determine the velocity of block A after it has moved 20 feet. Ang namagod sa book is ang displacement sa ato ang B ang gihatag, no? Ang displacement sa B. So our SB is equal to this is 10, and therefore our SA is equal to 20. So mao nang ang WB diri so that is 300, and then here is 20 times 1 half is 10, then minus ang atong frictional force, pila to itong nako kaganiha, 34.64. So 34.64 plus ang weight ni A is 200. So 200, that is sine of 30. SA is 20. That is equal to 1 half. Then weight ni A kay pwede po natin siya enclose no? Weight ni A is 200 over 32.2. And then plus 1 half ang weight ni B kay this is 300. So 300 over 32.2, and then natay 1/4 ani no, because of this 1 half BA niya gi-squared, so 1/4 ni siya. So diri sa right side of the equation ako lang gi-factor out ang BA squared, so that makakuha ta sa value sa BA, which is equal to, so we have 300 times 10 minus 34.64 plus 200 times sine 30 times 20 all over 0.5 times 200 over 32.2 plus 1 half times 300 over 32.2 times 1/4. Okay, pila may velocity ni A. So we have 300 times 10 minus 34.64 plus 200 sine 30 times 20, then 0.5 times 200 divided by 32.2 plus 0.5 times 300 divided by 32.2 times 0.25 na lang ako ibutang sa 1/4. Okay, so the answer is 8.48, or that is 8.5, no? 8.5, that is feet per second. So that is the velocity of our block A. So class, naipangutan na? SB o BB. Tungod din siya sa kaning sa pulley kani diri nga part. Lang ha, kani siya nga part diri Kani nga pulley. So kung mo displace ta diri og x, no? Displace ta og x dira nga unit. So ang mahitabo pod, so kani pod ato ang kuan, let's say nag-start po ni ang pulley diri ako layan na diri So kani pod nga part mo displace po ni og x unit. Siyempre, ang ubos mo displace og x, kani po nga part mo displace og x. However, kung imong kitaon ang kaning nga chord, no? So kung mo displace na ang chord og x, actually duha iyang daganan ani no, kung paubsan nimo og x diri motuyok man ni siya mo ana usa ka x and then duha ka x. usa niya maka-displace ni siya og ana. Na-gets? Mutuyok pa siya kausa mao na kung sa duha. Kung katuloon ni og tuyok, so 3 times pud siya. So diri kikausa ra man ni. So kung moubos ni siya nga part og x, no? Ang ma-displace ani nga row ani is 2x kay padiri so padira So mao nang ang atong SB is half lang sa atong SA, or ang atong SA is kanang kaduha or twice our SB. So mao ni siya nga relation. Nakuha ra? Okay, how about the others? Wala na pangutana? Okay, so ako lang i-end ang kuan.